Assalamualaikum and hello to everyone. So in this tutorial video, we will continue to look at how to fill in the cooling load estimation table for the next section, which are section B, transmission heat gain, section C, internal heat, and also section D, outside air sensible. Okay, so we start with section B, transmission heat gain. So the first blank we have to fill in is the area for all glasses. Okay, so based on our area table, we can calculate the total area for all the glasses present in our floor. Okay, so we have the window for the east 130, for the west 130, and also for the south we have 130. And then don't forget our doors are also made from glass, so the north has 70 and also for the south has 70, so the total here will be 530 square feet. Okay, so this value we will fill in the blank here, so 530. For transfer coefficient U, we will refer to table 9. Okay, so table 9, we will look at the transfer coefficient. So our glasses are all located on the external wall. So in table 9, we will look at external wall. We will look at the material for glass, and we'll read for the value for U. So the value here is 1.13. Okay, so here we can put in the value 1.13. For temperature difference, we will use the dry bulb temperature difference. So here is the value 17. Okay, so 17 here. So here we will use the value for dry bulb temperature difference 17. So then we calculate the total. So the total for all glass here will be 10,182. 181.3. Okay, next, wall. Alright, so wall which are not exposed to the sunlight. In the last tutorial video, okay, we have filled in for the solar heat gain for the east and west. So here we fill in the wall which are not exposed to the sunlight. So we have the north and also the south wall. Okay, so the north and south wall. Alright, so the area for north wall is 580. Okay, and then we times with the heat transfer coefficient, table 9. So still external wall. Our material is 4.5 inch brick wall. The value is 0.48. Okay, so 0.48 here. And then for temperature difference, we will still use 17 Fahrenheit. But this time we will minus it with 5. Okay, then we will calculate the total here. So the total here will be 3,340.8. Next, for south, okay, the area here is 450, wall only, and then times with the value for transfer coefficient, table 9, same. Okay, if you refer to table 9, external wall, 4.5 inch brick wall, the value is 0.48. So here we also put in 0.48. The temperature difference, okay, so we can put in the temperature difference 17 minus with 5, so we can get here the total. We calculate 2,592. Okay, so for partition, since we have already calculated all the wall sides, we don't have to fill in partition. For ceiling, since we have calculated the roof in the previous tutorial video, so we can leave it blank here. For floor, okay, so we look at the table, area table. We have the floor area here, 4,225. Times with, for the transfer coefficient, we have to refer to table 9. Okay, so here we have floor. And for floor, I have already in the notes and also in the video lesson mentioned that for floor, the heat will flow up. Okay, so for floor, heat flows up, the value is 0.25. Okay, so 0.25 here times with the temperature difference, so 17, but right now will be minus 2, so we can calculate the total here. The total is 15,843.8. Okay. For infiltration, we will neglect because we assume that there are no open windows or open doors. There are no cracks or holes in the wall. Okay, so we can leave it blank, and then we can calculate for the total for transmission heat gain. We add all this number up and we can get the total. So when we add all this number up, the total will be 31,957.8. Okay, so we can highlight this value, okay, in our cooling load estimation table. So next section is section C for internal heat. Okay, so for people, number of people, we know from the question 50 people, or we can read here from the ventilation table, so 50 people. So we can put in the 50 times with the value from table 10. Table 10, okay, when we look at table 10, we want to read for the sensible heat factor. Okay, so how to read the sensible heat factor? We can look either at the degree of activity or typical application. So for our space is general office. So the degree of activity, we here have office worker. Okay, and the typical application is offices. Okay, so we can read the value here. Okay, for office worker, typical application office, under the typical of Malaysia column, okay, we will read the value for sensible. So the value here is 245. Okay, so we put here 245. Okay, and then we multiply with 50, we can get the total here. The total here is 12,250. Okay, for lights, okay, the area for the floor 4,225. Now, times with the value from table 1. From table 1, we want to look for the occupancy lighting. Okay, from the question, okay, inside the space characteristic table, the question has already give the occupancy lighting 4 watts per square feet. But if the question does not give the occupancy lighting 4 watts per square feet here, for example, we can refer to table 1. So when we refer to table 1, okay, under application, remember that we have already chosen our application previously. So our application is office building. Okay, so under the occupancy lighting column, okay, we will look at the watt per square feet and we will read the value for average. Okay, so for office building, occupancy lighting, watt per square feet, the average value is 4, same as our question. Okay, so if the question does not give the value for occupancy lighting, we can read it from table 1. Okay, so the value here is 4. Type factor based on our bulb. Okay, so now our bulb is fluorescent, so type factor for fluorescent is 1.25. Okay, times with 3.4, our conversion factor. So the total here will be 71,825.0. Okay, so for equipment, now for our space here, our office here, it does not mention the equipment. So if the question does not mention the equipment, we can leave it blank. Okay, but for your assignment and mini project, make sure there are equipments. Okay, because it is not logic that for a floor space, for a space to have no equipments at all. Okay, so we can leave it blank for this question, and then we can calculate for the total of C. We add these two values. Okay, so we can get the total here for C. Alright, we can get 84,075. Okay, so we can highlight this value up. Okay, just like before. And then the next is to calculate the total for A plus B plus C. So total A plus total B plus total C, we will add them up, and then we can get the answer here, 164,936.8. Okay, and then we have to calculate 10% safety factor from the total just now. So 10% from here, we can get 16,493.7. Okay, and then we add up number 1 here and also number 2 here. we add them up to get the total room sensible heat, or RSH. So the total room sensible heat will be 181,430.5. Okay, we can highlight this value with a different color. Okay. Alright, next is section D for outside air sensible. So for outside air CFM, we will write the highest value for CFM, which we have highlighted before. Okay, so here the highest value for CFM is 1056.3. So we will use the value 1056.3 times with bypass factor from table 12. Okay, BF is bypass factor. Now bypass factor, sometimes in the question it will give the bypass factor. If the question or your mini project and assignment we don't have the bypass factor, we have to read from table 12. Okay, so from table 12 for bypass factor, here we will look at the example first. Okay, the most suitable example. Okay, so for our space, which is general office, when we look at the first example, resident is not suitable. For the second example, we have here small retail shop and factory. Okay, so inside factory there is general office. Inside shop also can have general office. The next example, department store, bank, factory also same, can have general office. Okay, and the next example we see here, department store, restaurant and factory. Restaurant, I don't think so have general office. Okay, so our most suitable example is the second and third example. Okay, so after we look at the example, we look at the application. Okay, so for both of these example, it writes here typical comfort application. Okay, so both example refer to typical comfort application. So our values can either be from 0.1 to 0.3. Okay, we can choose the value from 0.1 to 0.3. Okay, but to be safe, we calculate the average value. Okay, so the average value here between 0.1 and 0.3, the average value is 0.2. Okay, so we will use the average value 0.2. Okay, so for here, bypass factor, we will write the average value 0.2. Okay. If we know what type of system we want to use, okay, say we want to use package unit, okay, for our building, then the value will become 0.3. If we want to use a centralized air conditioning system, okay, chill water or centralized direct expansion system, okay, the value is 0.1. Okay, so if we know the system, we can use either these values. But if we don't know the system, we have to look at the example, we have to read the type of application, and then if possible, if required, we can calculate the average value. Okay, so here the average value is 0.2 times with 1.09, the conversion factor. Now the temperature difference is also 17. Okay, dry bulb temperature difference. Okay, so we can calculate the total here. Alright, so we can get the total here 3914.6. Okay, so next is to calculate the total effective room sensible heat, ERSH. So 1 plus 2, the value here just now, which we have highlighted in blue here, 1 plus 2, and then plus with the total in section D. Okay, so the value here highlighted in blue plus with the total from section B, section D here, 3914.6. So we can get the total here 185,345.1. Okay, so this value we can highlight it with another color. Okay, let's say purple. Okay, because later we will use this value. Alright, so this is an example for the next part, part 2, which we see how to fill in the transmission heat gain, internal heat gain sensible, and also outside air sensible. Okay, so thank you for your attention and have a good day.